Greetings, everyone. We are the Group 2, and today we are pleased to present to you our tsunami case analysis. Together with my group mates, I, Jamela Guliman, here together with Kate Camille Palo, Lucella May Villanueva, and Christopher James Valerta.
So here are the contents for this tsunami case analysis. The first case is the Hunga Tunga Hunga Hapai eruption and tsunami. Then the second case is the Sunda Strait tsunami.
Let us not forget about the third case, which is the Sulawesi earthquake and tsunami. And last but not the least, the Aegean Sea tsunami of 2020.
So let us start with the first case. At roughly 5 p.m., the Hunga Tonga volcano erupted, which generated a tsunami that affected the entire Pacific Ocean. The tsunami was also found to have affected parts of the Mediterranean Sea and the Atlantic Ocean. Triggered by the eruption of the volcano, the tsunami went as high as 65 feet above sea level, which caused hundreds of structures to get destroyed, 5 lives and 15,000 individuals displaced. Due to the widespread nature of the tsunami, injuries varies as there were a total of 18 injuries, with 14 being from Tonga, 1 from Japan, and 3 from California. So let's get to the solving. We use the formula 356 times the square root of the height. So in this case, the height, which is 0.075 kilometers. To solve this, we need to solve for the square root of height, which is 0.27386127.875. Then we multiply it by 356, and there we go. We solve for the tsunami speed, which is 97.49 kilometers per hour.
The second case, which occurred on Saturday, December 22, 2018 at 9:27 p.m. was when the coastlines of Lampung and Barten in Indonesia were devastated by a 3-meter tsunami which followed the eruption of Anak Krakatau, a volcano located on the Sunda Strait between the Java and Sumatra Islands. The waves generated by the volcanic eruption went up to 13 meters high, causing the death of 437 individuals, injuries of 13,000 people, and the destruction of numerous properties. This tsunami would later be known as one of the deadliest and most destructive volcanic eruptions since its 1883 eruption. So in this situation, we will solve for the speed again, and the tsunami's height is 0.013 kilometers. So the first thing that we are going to do is find the square root of the tsunami's height, which is 0.115758369. Then we multiply it by 356, and then we got the answer of 41.20 kilometers per hour, which is the tsunami's total speed.
Then the third case occurred on the Indonesian island Sulawesi, which suffered a large 7.5 magnitude earthquake, which was followed 5 minutes after by a 9.8 feet tall tsunami. Multiple infrastructures suffered extreme damage as 500 aftershocks occurred after the primary 7.5 shock. Sulawesi officials received damage and injury reports for over 3 days as widespread destruction spread from Palu to Donggala or central Sulawesi. 2.4 million lives were estimated to have been affected, with a death toll of 4,600 injured and at least 210,000 people displaced. Due to the massive destruction and widespread tragedy, major health risks were observed, such as lack of clean water, food, sufficient shelter, and proper sanitation. In this situation, we'll first find the square root of the tsunami's height, which is 0.006096 kilometers. So the square root of the tsunami's height is 0.07807688518. Then, as usual, we will multiply it by 356 and we will get the answer of 27.8 kilometers per hour.
Lastly, the fourth and the last case, which occurred on October 30, 2020, the Samos Island in Greece and Izmir province in Turkey were devastated by a strong earthquake and tsunami that hit the coast of both places. The tsunami reached a maximum height of 2.3 meters and was observed to have occurred in Kalechi region in Sigacin, based on research done and through 2 post-tsunami surveys conducted by the national teams. More than 70 lives were taken in Turkey alone, and survivors were reported to have been found under wreckage of buildings and structures. At least 962 people were injured by the earthquake, and the tsunami that followed caused street floods in parts of Izmir and Samos. On the last case, we will again solve for the speed, and the tsunami's height is 0.0023 kilometers. So once again, we will find its square root, which is 0.0479583153. Then we multiply it again by 356, and we will get the answer of 17.07 kilometers per hour. And that is the speed for the last case.
With all of these findings, we can all conclude and recommend that tsunamis are powerful natural disasters that can cause widespread destruction and loss of life. Therefore, therefore, it is crucial to be well prepared and informed in order to stay safe and minimize the risks. One of the most important aspects of tsunami preparedness is to identify safe evacuation routes. This means identifying high ground or safe shelter areas that are outside of inundation zone, and be familiar with the fastest and the safest routes to get there. Another key step in tsunami preparedness is to have emergency supplies and equipment on hand. This includes things like food, water, first aid kits, and flashlights, and other essential items that can help individuals and families survive in the aftermath of a tsunami. It is also important to stay informed about local warnings and alerts, such as through radio or TV broadcasts, in order to know when to evacuate and what to expect. Additionally, having a clear communication plan in place with family and loved ones is crucial. This means designating a meeting place in case of separation, exchanging contact information, and practicing communication methods such as text messaging or social media. By taking these necessary measures ahead of time, individuals and communities can be better prepared to face the challenges of a tsunami and reduce the potential harm caused by this powerful natural disaster. Thank you for your precious time in watching this presentation. Have a blessed day ahead.